All right, so I had made a Viper Orb engineering part 2 and part 3, but I unlisted them. Kind of wanted to just summarize um, everything and kind of show off the final result. So um, this is Viper Orb Mark 1. It is much larger, and after painting, the mechanism started seizing up and not performing as I had wanted. It's very stiff, and things jam up. It's oof, yeah, things are jammed up right now, and you can see there's a lot of places where I sanded down the paint because things were, like I said, things were just getting jammed up, and it's not true to the motion of the model in game. So all of this said, I went back to the drawing board basically, and I started from scratch. So first thing I did was I pulled up the motion of the orb in game. So I'm going to go in and kind of show a slowed down video of that right now. So in that, you can see that all three petals, they don't really move outward. They're just moving up and around. So it's I kind of explain this in sort of the CAD or the design breakdown, but I want it to move up and I want it to rotate, which is technically two axes if you're looking at cylindrical coordinates. Um, Mark 1 was heading outward as well. So there was a radial component as well as Z and rotational. So one of the reasons why Mark 2 works so well, I think, is because it's constrained to those two motions. It's circular and it's up and down. So this is how it functions. Now, it does jam up maybe 50% of the time. However, I am 95% happy with it because while it jams up, it doesn't take a lot to unstick it. There's a trigger on the bottom. That's this I refer to as the plunger. By tapping this, usually gets it that last little ways right now. And I've brought up lubricant before. There's none in here. There's some ballast in here. I call it ballast. It's two nickels. So yeah, and then the other failure mode is sometimes the plunger and the carriage don't fully follow each other on the way up. But for the most part, it's a really good motion, and it's very close to being complete. It just needs this last little motivation to finish the rotation. And even then, like it rotates on its own 50% of the time. So I'm going to go and show another PowerPoint presentation kind of detailing the design, explain the part names and everything like that. And then I'm going to go and show an assembly of this to kind of go talk about some of the specifics, because that design breakdown was made maybe a week ago, and there have been some minor, I mean, there's small changes, but they make a big difference to performance. So this is kind of similar to Mark 1, where I had a little presentation of just the CAD and kind of showing how the parts and the mechanisms all work together. This is it for Mark 2. As you can see, much closer to that. It's an in-game model in terms of shape, and as a whole, it's much simpler than Mark 1. It's 8 pieces as opposed to 19. And that's simply because the motion is kind of less complex as well. And I'll probably have talked about that before or after this. So the core of everything are these 3 pieces here. So I call this the plunger. It has press fit slots for magnets. Those magnets transfer its motion to the motion of this green carriage,
called the carriage because it carries the pedals. Um, and I I don't think there really was a way of kind of combining these in one piece and then having the spiral be there, because this does need to like trace around 360 degrees if I want to capture its motion. So there's no way of sort of having them be connected, because then that would like you would need a slot 360 degrees around that it travels on. And then I wanted to put things in the center. So this was sort of my preferred way. Plus, I've kind of become magnet pilled, and integrating magnets into 3D prints recently has been really good. This is the spiral. I put out a video a little while back explaining that I wanted to go and change up the slots. The slots were originally vertical, and now with them sort of along the slope, it means much better access to go in and sand on those surfaces and make them smoother. The motion, I'm not sure if there's a better way of better place to demonstrate it, but the motion of the plunger in the spiral is you start from this pit, you go up to the top, you kind of spiral around down to maybe a third of the height that you're at, and then you drop back down into that pit. So it's kind of like a click pen, except the clicking, you don't right. A click pen would have a sort of notch here, which would be a higher point, and then you have to press it up again, and then go down the spiral and drop into the low points. But there's only one point. There's no low and medium. There's just low. So, and then this was a pretty ingenious way, I think, at least, of having the pedals axles interact with the carriage. So because everything is flexible, because it's all made of 3D printed plastic, I can kind of flex the carriage out and stick the axles of the pedals in that way. Um, and I thought it was a pretty good, just design choice, because you're not using some rigid body. You're using plastic, so it's good DFM, I think, designed for manufacture. Some other little tidbits. So this is it at sort of stage 2, when it's raised fully, and the motion of the actual carriage is pretty simple. I kind of explained it. If you're using cylindrical coordinates, I'm not sure how many calc or high school math classes, I should say, used or taught students about cylindrical coordinates, but basically the carriage is rotating around, and it is translating up in Z as well, and that's all just due to the motion of the plunger driving it with via the magnets. Now, while its motion, has no sort of radial, uh, direction like Mark One did. Mark One's radial direction I achieved with the wedge and everything like that, and it was, I, I mean, it's not true to the animation, for starters, to the in-game models animation. So, this simplifies things. It keeps it to two axes if you're referring to cylindrical coordinates. However, the pedals themselves rotate about, because their center of gravity is offset from the axle. So because it's deeper, as the carriage lifts up and lifts them off of the cap, the pedals will rotate in a completely different axis than everything else is. And I thought that was a pretty ingenious idea. So this is it. This is where I was having. This is sort of stage 3, when you can kind of see it's the slopes of the pedals are just hitting the cap, which pushes them outward again and resets them. This is also the stage where I was having difficulty a little while back, and why I made the transition to this to go and clean up the slopes, because things were getting stuck at this point, where the carriage was not rotating them back into position because they were resting on top of the pedals here. So I I mean, that's just adding to the friction that the plunger is experiencing down here. So just the combination of those two meant that things were jamming at this sort of final stage right before things reset. Um, so yeah, that's kind of it. I've tried to explain the mechanism a little bit. Maybe I haven't fully, but it'll all get demonstrated as I put it together and assemble it. And like I said, these are some of the more ingenious design choices I made that I think help aid the uh, the knickknacks, the contraption's motion.
All right, so this is the disassembled orb, and now one other design change I don't mention in the presentation, but I mentioned it sort of in my intermediate videos, is I split up the spiral from the base. That's how I refer to each of these, and that is not true for Mark One, of course, where the spiral was embedded into the base, and that is because this went through a lot of iterations and changes. And because I knew that this was going to be very important, get right, I separated it out so that I didn't have to reprint this every single time. So I only printed the sort of the base a singular time, and I'm glad I did that. There is some like interfacing details there, the interface with slots on the bottom, and as you can see, everything is painted. I think I did a pretty good job with the painting. I might sand it down with the 800 grit one more time and do one last layer, but everything's looking good and functions while being printed. Now, as I kind of explained in the video, having the slots on the spiral here allow me to sort of sand in there and clean this up, which I've spent a lot of time this weekend doing, and that helps with the motion. Now it's not perfect still, like I said, it does jam up, but on their own, the plunger and the spiral, if it's just these two, it works beautifully. One change I also didn't mention in the presentation there was this was the spiral back in my intermediate videos. If you saw those before, I unlisted them. The two magnets on the top are closer than these ones here. Now I went through several iterations of the plunger as well, trying to find a perfect sort of ratio, because I wanted the attraction force between the plunger and the carriage. I needed that to be a certain strength. I didn't want it to be so strong that it clamped things together and prevented movement, but I also wanted it. One issue I was having earlier when with this one, where the magnets are tighter together, is that there's not enough force holding up the weight of the carriage and the three pedals on top. So this was kind of sagging a little bit, and that was jamming up movement between these two. This right here, or the ratio that I've got right now, is, I think, is nearly perfect. And like I said, I know it jams up still, maybe 50% of the time, but it's still close enough that everything, all of the motion still kind of happens, if that makes sense. Things were really getting stuck with this, and with the previous one I already tore it up to get back my magnets. There's a previous plunger that had the magnets spaced out really far apart, which meant that the carriage was clamping things and holding them in place. So, one other thing I didn't talk about in the presentation is I have ballast now. This is 2 nickels. There's a piece of painter's tape in between them, just so that they don't clink as much. There's some slight problems with it jamming into the spiral slots, but this just adds weight to encourage the plunger to go down. This is one of the things that mitigates the motion a little bit, and helps it from getting jammed as much, because it was getting jammed up a whole lot more. I think like 80% of the time, 75% of the time. Just a week ago when I didn't have the spiral changes, and yeah, so the ballast helps. Now I don't know, I might add some sort of ring to this so that it doesn't slide around within the spiral, like just some 3D printed ring. I've looked into other sources of weight, but frankly, I think 2 nickels, 10 cents is cheaper and will perform the function admirably, you know, than buying some sort of like, not lead per se, like some zinc weight that I was looking at. Here is the, what did I call this? The cap. It's painted very nicely. One thing that the presentation doesn't really show off is, you know, all the beautiful colors I've got going on. You can see the cap when the spiral is coming through. So everything in here is painted. I painted the inside of everything as well. It all looks very nice, I feel. And yeah, it all comes together real quick. And like I said, it just needs that last little bit of encouragement. And right now, I am okay. I am satisfied with this result. I'm satisfied with this result. It's not perfect, but it's 95% of the way there, and I can accept that, especially because there are some additional things that I can try on the side. But here we go. This is my Viper Orb. I'll show one last video of it in game, so that you can kind of go and compare its motion. But it's very good, and just that last little bit, and I think just a touch of Vaseline, maybe a little bit more sanding is all it needs to perform like at 100%. But right now, 95%, 90%. I'm happy with this. I'm very happy with this, and yeah, I'm gonna move on to other 3D printing projects very shortly.